No, well, it's yeah, probably. No, there's some, but okay. This is Unit 7 Rational Functions Review, and number 1, consider the rational function, and here's your rational function. Completely factor both the numerator and the denominator. So let's do that first. How would you factor the numerator?
Two parentheses.
Okay. So.
Oh, we don't have a paper over
Y'all didn't get one?
Nope.
Oh.
here. Blame Nathan.
Here you go. Pass those down. That will help. Okay. Okay, 2 parentheses. You got any ideas here?
And
Maybe 3.
Okay, like 3.
Wait.
And 3 times 2 is 6. And which one's negative though?
Positive 3, negative 2.
Cody, which one's negative?
The 2.
The 2. Good. Okay, so we've got 3x and negative 2x. When you do these outside and inside terms, gives you a positive x. Okay, and then on the bottom, this is a little trickier. What can you take out of the bottom? What's common in both of those?
A. 2.
A 2. Okay, so we'll have 2 parentheses. Then what would be 2 times what would give you 2x squared?
X squared.
Dylan, x squared. Okay, minus 2 times what gives you 18? 9. Okay, now can you factor x squared minus 9?
Yeah.
Okay. What would it factor to?
X plus 3.
Okay, so I'm going to write this again. X plus 3 times x plus 2 over 2, and then we'll have 2 parentheses for that. We'll have x times x. And what about the 9? Y'all should know this. Anybody? 3 and 3 will give you 9. So 1 negative and 1 positive, that would give you a negative 9 when you multiply them. And then when you add your middle terms, negative 3x and positive 3x is 0. Okay, then it says simplify the expression. How could we simplify it?
Take out the x plus 3.
Good, you can cancel those out. Just mark them out though, don't completely cover them up because we're going to need to look at that in a minute. Okay, so what is the equation of the vertical asymptote? Which one's the vertical asymptote?
No. Denominator.
Denominator, and it's the one that's not canceled out. Okay, and so it'll be this x minus 3. We set that equal to what? 0. Then add 3 and x equals 3. So there's your vertical asymptote. Okay. Then it says at what x value is the function discontinuous? Or what is the type of discontinuity? What does it mean when we cancel out the x plus 3's? Y'all remember that? Remember that paper, Remove the Bull, that's in your journal? Remember Remove the Bull? So what happens when these cancel out? What does that create in the graph? It creates an error on the table. Okay. Huh? A gap. A hole. It creates a gap or a hole, and so this is called a removable. Remember that? Removable discontinuity. So in your journal, you can look for that page. When it asks for what kind of discontinuity, this is what you're looking for. And it occurs where? What canceled out? What was the thing that canceled out? X plus 3. So we said x plus 3 equals 0 and x equals negative 3. So if you were to graph this and look on the graph at negative 3, you would see a hole. If you were graphing in your calculator, you would have to have the correct window to see it. But okay, and why was this a removable discontinuity? Because it was removed from the equation, from the expression. Okay. Okay, number 2. Elijah. Find the vertical asymptote of the equation below. Where's the vertical asymptote? In the top or the bottom?
Bottom.
Okay, wait, this is Elijah.
Oh, sorry.
Where's the vertical asymptote, in the top or the bottom?
Denominator.
Denominator, okay. So what would it be? What would be the vertical asymptote? X equals what?
4.
4, yes. Because 4 would make that 0. Or you can set that equal to 0 and solve, and you get x equals 4. Okay, everybody should get this one right tomorrow. Okay? Okay, number 3. If the x in a rational parent function 1 over x is replaced with x minus 5, how is the graph changed? So the equation would be 1 over what? We replaced x with x minus 5. Be 1 over,
X minus
right. Okay, so what does that minus 5 do to it?
C.
See, the graph is shifted right?
5. Yes. Correct.
When it's down there with the x, it shifts it left and right, and it's always opposite. Minus 5 would be right 5. Okay, what would make it go up 5?
X plus parentheses.
X press.
Okay,
X
like-
and then plus 5 outside of that.
right, it wouldn't be down there in the bottom with the x. It would be out to the side, plus 5. Okay. Okay, Rhonda is looking at a table of data representing a translation of the function y equals 2 over x. What's a translation mean?
Shifted.
Shifted, okay? She notices that when x equals negative 3, the table says error. Okay, what does that mean?
Maybe that's.
Maybe an asymptote, okay? She notices that as the x values approach negative infinity, they get really, really small. The y values seem to approach negative 4. And as the x values approach positive infinity, get really, really large, the y values seem to approach negative 4. Then you have to write the equation. Okay, so we're going to do y equals, okay, we didn't stretch it or compress it any, we're keeping the 2. But we did shift it. Okay, if there is an error at negative 3, what does that tell you about down here?
X plus 3.
Okay, you did the opposite y.
Okay, it's setting it to 0.
Okay, if you set that equal to 0, you get negative 3, don't you? Also, it means that the vertical asymptote's at negative 3, so this needs to go left 3. What does this take?
I don't know. That part.
That is, this part out here, that is your horizontal asymptote. And that means it went down 4. Okay. When you put in large numbers for x, that tells you your horizontal asymptote. Okay. And it's also the range, which is out here. Okay, so put a star by this one, and y'all study this one. Okay. Because you can get this right if you just know that the error is at the bottom and the horizontal asymptote is to the right. Okay. Okay, number 5. A swimming pool can be filled with water in 3 hours. It can be drained in 5 hours. If the pool is being filled and drained at the same time, how long will it take to fill the pool? Okay, so what are we doing here? Filling the pool or draining the pool?
Doing both.
We're filling it, but eventually it's going to fill it up. So it's filling faster than it's draining, right? Okay. What's it filling at?
3 hours.
So how do I write this? You remember these?
No.
1 over 3 plus, or not plus, since we're draining it, it would be minus. What would
5.
1 over 5 equals 1 over x. Okay. The hours it takes to fill, minus the rate that it's filling minus the rate that it's draining is going to equal the rate that it takes to fill. Okay. Okay, so how do we solve it?
You times like
The 15 and the x. We're going to times everything by 15x. So 15x put 15x by everything. Okay, and 3 goes into 15 how many times? 5. So we have 5 times x times 1, which is 5x. Okay, then 5 goes into 15.
3.
So 3 times x times 1 is 3x. Okay, what cancels out here?
X.
Okay.
So that equals 15. Good one. Solve it. Okay, well, what do we do to solve it?
2x.
Okay, 5x minus 3x is 2x. Then, so x equals, you can leave it as 15 halves, or you can divide 2 into 15. It'll go 7 times with 1 left over, so that's 7 1/2. Or you could even put 7.5. It'll probably be multiple choice, so you'll need to see. It could be in any form, a decimal or a fraction or a mixed number. Okay, number 6. The time and hours required to paint a building varies inversely, underline inversely, as the number of workers doing the painting. Okay. So we have hours, we can call that H. Required to paint a building varies inversely as the number of workers, we'll call that W for workers. Okay, and you remember what inversely, do you remember the equation for it? Y equals something over X. Do you remember? What's it? Yeah, you do. Remember K?
Yeah.
Okay. Here, you're going to need to know this tomorrow. Okay. This is in your journal, so look for it. Okay, where it says inverses and where it's variations. Yeah, you might want to get your journal out and kind of look. You're going to use that equation for inverse. What's one for direct? You remember? Y equals KX.
Miss Walton,
Yes?
I need Logan Taylor and Ian Villa with their things, please.
Okay, Logan is not here,
Logan's not here. Okay.
but Ian
All right.
is. Okay.
Thank you.
Okay, so we're going to plug in hours for the Y. The first one goes for the Y. Equals K over and workers for the X. We did problems like this. Do you remember at all? Okay. All right, then we're going to plug in what it says here. If it takes 11 hours for 16 workers to do the job, so stop there. And we're going to plug in 11 for hours and 16 for workers, and that's going to help us find K. So multiply both sides by 16. 16 times 11.
176.
Okay, so K is 176. So now we're going to plug that back in here for K. All right, so we get H equals 100. I'm going to put it over here so it's kind of, H equals 176 over W. Okay, then it says how long will it take 8 workers to do the same job? So where do I put the 8? W. Okay, so H equals 176 divided by 8. $22. And that was one of them. Okay. Bless you. Bless you. Okay, questions? You remember doing these? We did a lot of these. Okay, bless you again. Okay, number 7. Which is a direct relationship?